This is AP Calculus BC, Chapter 2, Objective 3B, so quotient rule, plus also some trig rules as well to finish those up. And then we're also going to start Objective 4, chain rule, but just the very beginnings of it. Okay, so kind of like baby chain rule, think of it like that. Okay, so let's start with quotient rule. So I'm going to abbreviate that with QR, so QR is quotient rule. And so given a fraction, so a rational expression, so say f of x over g of x, so we would use quotient rule if f of x was a polynomial, so a variable expression up here, and g of x as well was a polynomial with a variable expression. So if these were both variables in the numerator and the denominator, then we would be using what we call quotient rule. And there's get around, so like if you decide, ooh, I hate quotient rule, there's other things we can do. All right, so here is quotient rule. So if we have y prime is equal to, or the derivative, sorry, if y is equal to f of x over g of x, then y prime would be g of x, oh, hold on, sorry, I have like a phone call coming in, it's bugging me, there we go. So g of x times f prime of x, and then minus f of x times g prime of x. And then all of that is divided by g of x squared. And that is what we call quotient rule. So you can see, like, you look at that and you're like, yeah, lovely. And not so lovely, right? So this is our quotient rule, so that's how we would find that derivative. But there is like a lovely little kind of a chanty kind of thing to help us remember that a little better. So f of x is our numerator, and so we refer to that as high. High meaning it's high, it's above, right? Not hello high, but high meaning above. So a numerator. And our denominator we're going to refer to as low. Low as being below. Okay, so low as in being below. So this right here, so this is low, so g of x is low, right? We just take that denominator, the low, and then we're going to multiply that by the derivative of the high. The derivative of the high, so that would be d for derivative and then high. So that would be low d high. So low d high. Low d high. And then minus high, high meaning the numerator. So the way it's written, right? No derivative there. And then d low, meaning the derivative of the low. So low d high minus high d low, and then the fraction bar we're going to say all over the square of what's below. Excuse me. Okay, so low d high minus high d low all over the square of what's below. All right, so there's our quotient rule. So let's go ahead and we're going to do one example before we get into the next rule that we're going to do. Okay, so that's our fraction. So x squared plus 2 over 2x minus 7. So this I'm going to refer to, again, this is my high and this is my low. So high meaning it's high, H-I-G-H, not hello high, low meaning below. And so I'm going to go ahead and do quotient rule for this. So our quotient rule, so y prime. So low d high minus high d low. So low, I just write down exactly what I see in the denominator, so 2x minus 7. So there's my low. And then now I'm going to do d high. So I'm going to put a 1 here because there's an implied 1. So d high, so the derivative of the numerator, so 2 times 1, and then reduce the power by 1, and then the derivative of a constant, so the derivative of 2 is just 0. So there's the low, and then the derivative of the numerator, and then now minus, so now I'm going to take the high, so x squared plus 2, and then I'm going to multiply that by the d low, so derivative of the low. So there's an implied 1 here. So 2 times 1, and then reduce the power by 1, so that would be a 0, and then the derivative of a constant is always 0. So all I've done so far is low d high minus high d low, and then now all over the square of what's below. Okay, so that would be my derivative. And then we can do a little simplifying. Like, I would never go crazy with the simplifying, not my style there. But I can do a little bit just for aesthetic reasons. So I know that like the 2x can go in the front, and that helps kind of eliminate all of those extra parentheses. I also know I can distribute it, but I'm not going to. And then over here, the x with the 0 is just 1, so that would just be 2 times 1. And then that can go in the front as well. And then I'm just going to leave the denominator the way it is. So 2x minus 7 and then squared. And so that would be just a kind of a basic example of our chain rule. Our quotient rule. Okay, so then the next piece that I want to go over is the trig, the rest of the trig derivatives. So we've already done 2 of them, so let me remind you of that. So we have our trig rules. So we already did the derivative of sine of x. So that was an earlier lesson. So the derivative of sine is just cosine. And then we also did the derivative of cosine, which is negative sine. So the new one is tangent. And that derivative is secant squared x. So one of the reasons that other trig rules are introduced into this particular lesson is because tangent is a quotient, right? Tangent can be defined as sine over cosine. So I could actually rewrite tangent in terms of sine and cosine, and then use quotient rule, and then with some lovely identities, turn it into secant squared. So if you ever forget the derivative of tangent, for whatever reason, and you have sine and cosine in your back pocket with quotient rule, you could actually come up with that derivative on your own. I'm not going to do that for you though, okay? So just keep that in mind. Okay, so there's 3 of our 6 trig functions. So we have 3 more though, right? Because we have all the reciprocal ones. So we also have the derivative of cosecant, which that could be defined as 1 over sine of x, right? And then I could do some quotient rule stuff, so 1 over sine of x. Or I could just memorize it, and that would be negative cosecant x cotangent x. So that would be the derivative of cosecant. And then we have the other reciprocal, which is secant of x. And I could rewrite that as 1 over cosine of x and then do quotient rule as well. And that derivative is secant x tangent x. But you notice that I'm not doing any of what I could do. I'm just going to memorize them as well as you should as also. All right, and then finally the last one is cotangent, and the derivative of cotangent x is negative cosecant squared x. And so those are our other trig rules that we have to know. So these 2 we already did, and here's the other 4. Okay? All right, so let's do another example. So for this one here, I'm going to do another quotient rule, but I'm going to throw in a trig one for kicks and giggles. So here is our second example. So for this one here, we have tangent of x over the square root of x and then plus 2. So that x plus 2 is not both under the square root, the plus 2 is outside. And so again, I have a quotient here, so I'm going to use quotient rule. So the tangent of x will be the high, root x plus 2 will be the low. And then just while we're right here, just a reminder, that's the same as x to the 1/2 plus 2, because I know I'm going to have to do a d-low at some point. So I'm just going to rewrite that into that power ready form. Okay, so the power ready form. All right, so let's give this one a whirl. All right, so low d high minus high d low all over the square of what's below. Okay, so we're going to start with the low. So low. So I'm going to leave it in the root form, but you don't have to. So low. And then d high, so the derivative of tangent is secant squared. And if you don't know that yet, that's okay. You could just look it up, right? So low d high, and then now minus high, so that would be tangent of x. And then d low, so I'm going to look over here this time for the d low, so I can do power rule over here. So I'm going to bring down that 1/2, so that would be 1/2. And then subtract 1 off of that power, so that would be negative 1/2. And then the derivative of a constant is 0. And then all over the square of what's below. So a very messy quotient rule, but there it is. Okay, so here is something that a lot of people don't like, and that is we need to make sure we do not have a complex fraction in our final answer. So this is considered a complex fraction because I have a fraction in the numerator of a fraction, right? So if you have a fraction in the numerator or the denominator or both, it is considered a complex fraction, and then we have to simplify that a little bit, okay? So in order for me to simplify that a little bit, I need to get that 1/2 not there, right? So I'm going to multiply the top and the bottom by 2, and that will get rid of that 1/2, right? So if I multiply by 2, 1/2 of 2 is 1, so that will reduce down to 1, so that's good. And right, and that doesn't change anything else. But then this is also a fraction, right? Not the fact that the power is a fraction per se, but the fact that the power is negative, right? Because that means 1 over the square root of x. So that means I also need to multiply by x to the 1/2. So that's not a complex fraction, right? So I'm going to multiply top and bottom, numerator and denominator, by 2x to the 1/2. And then I have to distribute it to both terms there. And then, so this is just going to be 2 root x, and then times that group there. I'm not going to actually distribute it, right? I'm just going to write it in front. And then now when I multiply it to here, the 1/2 and the 2 is equal to 1. Negative 1/2 plus 1/2 is 0, so that would be x to the 0, which is just 1. So all of that is just a 1, leaving just the minus tangent of x. And then all over, and then this would be 2 root x, and then root x plus 2, and then squared. And I just moved that to the front because of that standard form. And then these would not cancel because 2 root x is not a factor of the whole numerator, only a factor of the first term. Okay? All right, so that's kind of like our beginning looks at quotient rule. So that's like another rule we got tucked in our pocket now. So then now the second component is that objective 4 piece, which is chain rule. But remember, we're just doing the beginnings of chain rule. Right, so chain rule is a rule we use for when we have composite functions that we have to take the derivative of. So chain rule is used when we have more than one operation working on the same variable or same term, okay? So composite functions, just a reminder, one of those notations is something like that, right? F of g of x. And so chain rule just tells you the order in which you take the derivative. So you can never do more than one rule, so to speak, at a time in chain rule. You have to do them one at a time. So one following the next, following the next. So I would take the derivative of the outside function, so f prime, don't touch the inside yet. And then once you finish that rule, then you can multiply it by the derivative of the inside. Okay, so chain rule, one thing at a time, don't rush it, don't get in a hurry. Okay, so order matters in chain rule. So we're going to do a couple of examples here. Okay, so we'll start with, so this is example 3. So if we have y equals 4x squared minus 2x all to the power of 5. So 4x squared minus 2x all to the power of 5. So if you look at this, I have a couple things I have going on here. So I could take the derivative of that, which is like 8x minus 2, but then I have this 5 out here I have to do something with as well, but it's a power, so I pull down the 5, reduce by 1, right? So chain rule just tells us again, one thing at a time, don't rush it, and always start with the outside. So order matters on chain rule, always start with the outside. So I'm going to take the power of 5, because it's on the outside of that group, right? Power on the outside of the group, so y prime. So start on the outside group. So that would be pull down the 5, and then we know we're going to reduce the power by 4, right? So what we just did was the f prime. And so if we look here, g of x, that inside didn't change according to the rule. It stayed the same. So that means the 4x squared minus 2x has to stay here, doesn't change. Because that's what the rule is telling us, right? So then now it's saying once we finish that outside piece, now we can multiply by g prime, g being that inside piece. So now when I multiply, that's a dot there, I'm going to take this derivative. So that would be 4 times 2, reduce the power by 1, and then there's like a 1 there, and then 2 times 1, and then reduce the power by 1. And that would be chain rule. And so I can simplify this a little bit, so I'm going to go ahead and do that. So that would be 4x squared minus 2x to the power of 4. And then x to the 0 is 1, so that would be just 8x minus 2. And then I can leave it like that. And then you can distribute that if you want to as well. And then that's it. Okay? All right, last one here. So example 4. So for this one here, we're going to have y equals, and then the square root of 1 minus 2x. So I have to do a rewrite because we have to get it into power rule ready form. So that would be 1 minus 2x to the power of 1/2. So then again, I have that same situation where I have like this grouping here. And whenever I get that grouping, that means I need to use that chain rule, right? So grouping symbols, chain rule. So here we go. So y prime. So I start from the outside, right? Because order matters in how I do this. Always start on the outside. So I'm going to bring down that 1/2 power and then subtract 1 off the power. So that would be negative 1/2. And then don't do anything with the inside. So keep that exactly the same. And so now you've done the outside, and now you're ready to do the inside derivative. So multiply by, and so I'm going to put an implied 1 here. So the derivative of 1, so that's just a constant, so that would be 0. And then right here, so negative 2 times 1 is negative 2, and then reduce the power by 1. And then I can simplify that a little bit, or a lot, depending upon what you prefer. So that will still be just 1/2, 1 minus 2x, and then to the negative 1/2 power, and then x to the 0, of course, is 1, so negative 2 times 1 is negative 2. And if you want, you can go ahead and multiply that together. You can make that in the denominator. You can rationalize. You can always do anything you want. I prefer you stop right there. Easier for me to grade, and you're less likely to make common errors. And that is it.